गुड मॉर्निंग गाइस। सो आज हम लोग पीएनसी डिस्कस करेंगे, इनफैक्ट सम बेसिक टेक्निक्स ऑफ पीएनसी। Okay, let's see that. So guys, in PNC, first of all, before going to permutation, NPR and NCR, there are certain basic things such as when to add or when to multiply, right? So guys, basically we'll be discussing that as to when to add and when to multiply, right? Okay, so let's see guys, basically what do we do? I'll just explain this concept. When do we add and when do we multiply? Let's say there are certain tasks, right? There is this task, I'll say task number 1, which can be done in a number of ways, and there is this task number 2, which can be done in b number of ways, and then there is this, let's say, task number 3, right, which can be done in c number of ways, right? So basically, let's say the scenario is, first of all you need to do task 1, after that you need to do task 2, and after that you need to do task 3. So basically these 3 tasks are to be done in a sequence or in a series. Then in how many ways all of these tasks can be done? Guys, whenever this kind of scenario is there, whenever the tasks are in series, so in how many ways this can be done? We'll just multiply the number of ways. It will be A into B into C. So guys, whenever tasks are arranged in a sequence, you need to do all of these tasks, right, and in a certain order. Then what we'll do, we'll multiply. Now this is the case when we multiply. Now let's just think about when do we add, right? Suppose you need to do either task 1 or task 2 or task 3, right? So basically these are 3 tasks. You need to do exactly one of these, right? You do not need to do all of these. You need to do exactly one of these. Then what do we do? Then the total number of ways of doing it will be A plus B plus C. Guys, I'll repeat myself. If we need to do all the tasks in a given sequence, then we'll multiply to find out the total number of ways. If we need to do exactly one of these tasks, then we will be adding, right? So let's understand this thing with the help of an example, right? Let's see that. So first of all, keep in mind this thing, and this is the basis of PNC, right? We apply all the things, right? We derive the formula of NPR, NCR, arrangement, everything with the, with this, right? So that is the starting point here, guys. When to add and when to multiply, right? So guys, suppose there is a town named A, another town named B, and a third town named C. Let's say number of roads connecting A and B is 3, and the number of roads connecting B and C, let's say it is 4, right? Let's say the question is, in how many ways can a person travel from A to C? So in how many ways can a person travel from A to C? Again, if you think about this thing, just look at it this way. Can I say, basically this can be done in 2 steps or 2 tasks. Task 1 is traveling from A to B, and task 2 is traveling from B to C. So can I say this can be divided into 2 tasks. One is task 1, that is traveling from A to B, and task 2 traveling from B to C. Now in how many ways task 1 can be performed? Right guys, the first task is traveling from A to B. Can I say there are 3 roads, right? So a person can travel from A to B in how many ways? Either he can pick up this one, this road, or this or this. That can be done in 3 ways. Now in how many ways can a person travel from B to C? Right, can I say any one of these 4 roads? That is 4 ways. Now in how many ways can a person travel from A to C? Guys, again there is this thing, should we add or should we multiply? Let's just think about this thing. Can I say if a person has to travel from A to C, he needs to perform both of these tasks? First of all, he needs to go from A to B, then B to C. So since he needs to perform both of these tasks are arranged in a sequence, in a series, ek ke baad ek. So basically A to B 3 number of ways, B to C 4 number of ways. Total number of ways it will be 3 into 4, that is 12. So guys, since the tasks are in a series and the person need to perform both of these tasks, so we'll multiply. Now let's see an example of addition, right? Hopefully this thing is clear, okay? So let's see that. Suppose there is another town named D, and then the number of roads connecting A and D is 2, and the number of roads connecting D and C, let's say it is 5. Right. Now, let's say the question is, in how many ways can a person travel from A to C? Suppose we need to find out this thing. Then can I say, basically, guys, either the person will travel through B or through D. Guys, these are the two possibilities. The person will travel either through B or through D. The number of ways of traveling through B is already given. We know how do we find out. It is 3 into 4, that is 12. And then the number of ways of traveling through D, A to D is 2 and D to C is 5. So 2 into 5, it is 10. Now can I say the total number of ways of traveling from A to C will be, can I say one thing, the person will travel either through B or D, exactly one of these two towns, right? So basically whenever this kind of scenario is there, exactly one of these, right? So what we'll be doing, we'll be adding these two and our result will be 22. So hopefully basic thing is clear, when do we add and when do we multiply. Now as we move on, right, in the next questions, we'll be seeing a lot of application of this thing. When do we add and when do we multiply, right? So hopefully this thing is clear, right? Now let's go a little bit further. The next part is arrangement, right? So the next part is arrangement. Okay, suppose there are 4 friends A, B, C, D. They need to sit on these 4 chairs arranged in a sequence or in a row, right? In how many ways these 4 friends can sit on these 4 chairs? So again, if you think about this thing, in how many ways can these 4 friends sit on these 4 chairs? So basically what we can do, we can number the chairs, or the first chair, second chair, third chair, fourth chair, right? Can I say, in the first chair, any of these 4 persons can sit. In the first chair, any of those 4 persons can sit. The first chair can be filled in 4 ways. Now one of them must be sitting here. Now how many persons are left? The number of persons left is 3. Now out of the remaining 3, can I say any one of those can sit in the second chair? The second chair can be filled in how many ways? 3 ways. Now how many persons are left? 2 persons are left. Now out of these, one is sitting here, one is sitting here. So 2 persons are left. So the third chair can be filled in 2 ways and the fourth chair can be filled in 1 way, right? Now can I say, if we have to arrange these 4 friends on these 4 chairs, that means we need to fill all the 4 chairs one after the other. So if we need to fill all the 4 chairs, right, then can I say we need to multiply. The tasks are in a sequence, na? Task 1, fill the first chair. Task 2, fill the second chair. Task 3, fill the third chair. Task 4, fill the last chair, right? So basically, since we need to fill all 4 chairs, so we'll multiply. So our answer is 4 into 3 into 2 into 1. We can also write it as factorial 4, right? And its value is equal to 24. So number of arrangement, can I say if there were 4 persons, then the number of ways of arrangement were 4 factorial. So we can generalize it, this thing. So basically what we can write here, guys, what we can write here, number of ways of arranging n different things, number of ways of arranging n different things in a row is given by this formula, it is n factorial. I believe we have just seen it, how do we get this factorial thing, okay. So, arrange, it is called, basically it will be equal to n factorial, right, basic thing. Now, let us just solve some basic questions on the basis of this, right. So, I will just remove this thing, and then let us say there is this word relation, right. Now, the question is, how many 8-letter words can be formed using all of these letters? How many 8-letter words can be formed? How many 8-letter words can be formed without repetition or using all of these letters? Without repetition, what is the meaning of without repetition? It means no letter is repeated more than once, such that, then I will give you a certain condition. Let us say the first part is the word start with, let us say, a letter R. The word start with a letter R. Again, if you think about it, guys, not total number of words, right? The total number of ways in which these 8 letters can be formed. Obviously, since there are 8 letters, that is 8 factorial, or its value is 40,320, right? 1 into 2 into 3 into 4 into up to 8, right? We will be getting 40,320, but the condition, the first condition is word start with R. So, guys, tell me the answer. Yeah. Okay. Right. RK got 7 factorial. Priya is saying 5040, 7 factorial, right. So, everybody is getting the correct answer, right. Can I say if the first letter is R, now we just need to arrange the rest 7 letters. If the first letter is fixed at the first place, if R is fixed at the first place, then we just need to arrange the other 7 letters. The other 7 letters can be arranged in how many ways? Can be arranged in 7 factorial ways, or its value is 5040. Or its value is 5040. Second part, how many 8-letter words can be formed without repetition such that, this is such that, okay, not than, such that word do not end with n. Right, these words do not end with n. Yeah, guys, this is the second part. Try to solve this thing, tell me the answer, right. And again, if you are looking at the second question, we will forget about the first one, right. Yeah, guys, tell me. So, I will do one thing, I will just remove this first question, okay. The words do not end with n. Aditi, there is no fixed weightage in all, right? We cannot say that. For example, last year there were 2 questions, right? So, it can be 1, 2, 3, 4 or 0. It can be anything, right? But traditionally, they do not ask many questions. Basically, you will not be getting, let's say, 6 or 7 questions from permutation, combination and probability. Right, it will, I expect it to be around 2 question or 3, right, basically 2 or 3 question, right. Okay, so Ritu is getting 35,280, RK is also getting 35,280, Priya is getting 35,280, let's see that. Guys, the word do not end with n, right. First of all, what I will do, I will just make the 8 places, first, second, third, fourth, fifth, sixth, seventh, eighth. can I say at the last place we cannot write n. So the last place, if we cannot write n, so any of these other 7 letters can appear at the last place, these 7. So the last place can be filled in how many ways? 7 ways, right? The last n cannot appear. So any of these letters can appear at the last place. So in how many ways the last place can be filled? 7 ways. Now can I say there is no condition? Now no other extra condition. Can I say these 7 places? We have 7 available letters. One of these is here, right? Then we have 7 available letters and 7 places. In how many ways that can be done? It can be done in 7 factorial ways. But since we need to fill all the places, that's why we need to multiply. So our answer is 7 factorial into 7. So if I multiply, if we this, so we'll be getting 35,280. So all those people who got 35,280, excellent guys. So basically we have been able to solve this, not much of a difficult question, right? The word do not end with n, right? Okay. Now let's see the third question, which is the third part. Let's say A and T appear together. A and T appear together. Yeah guys, try to solve this one. Tell me the answer of this particular question. A and T appear together. Guys, you are getting it wrong. Power Star, Anuj, Ritu, Rohit. Sushil got it correct. Right. Okay. So it is not 6 factorial into 2 factorial. No, it's not that. Guys, basically, let's see how we'll be going about it. Since A and T appeared together, let's do one thing. Let's bind these two together, right? So that they do not get separated. So I pick up a rope and I have bounded these two together, right? Now how many letters are there? Basically we are assuming this to be a one single letter. So how many letters are there? Can I say 1, 2, 3, 4, 5, 6, 7. Now we are left with 7 letters, right? These 6 and these 2, right, they have become one letter. So overall how many letters are there? 7 letters. So those 7 letters can be arranged in how many ways? 7 factorial ways into y. Can I say here basically A is appearing before and T is appearing after A, right? So basically what we can do, can I say they can also be interchanged? Or these two letters can be arranged in how many ways? We can say 7 factorial into 2 factorial, because these two can be arranged in 2 factorial ways. So ultimately our answer is 5040 into 2. That is 10,080. That's our answer, guys, right? So hopefully you realize your mistake. It is 10,080. Okay. Just similarly, let's see, had there been a question, suppose they are saying that L, A and T appear together. Suppose these 3 letters L, A and T appear together, then what we would have done, guys, then we would have formed a group, right, containing L, A, T. Now how many letters are there? One is this, 2, 3, 4, 5, 6, overall 6. Then it would have been 6 factorial. Now these 3 letters can be arranged in how many ways? 3 factorial ways, right? So 6 factorial is 720 into 6, right? So it would have been 720 into 6, or our answer would have been 4320, right? Hopefully this thing is clear. Okay. So next, so basically this was third question, and then we saw the variation of third one. That was, I mean, I'll also consider third one only. Now let's say the fourth question is, and let me remove this part first, and also this one. Suppose the next part is A appears, or let's say question is there is exactly one letter, between A and T. Yeah guys, try to solve this one. There is exactly one letter between A and T. So what will be the answer? Yes guys, what is the answer? So there is exactly one letter between A and T. Okay, so Ganesh is saying 6 factorial, Anuj is saying 6 into 6 factorial, Arnav is saying 6 factorial into 2 factorial, right? Dhananjay, you got 12 factorial into 6 factorial. You know, na, that is greater than the total number of ways. Our answer must be smaller than this, na? We cannot get any answer which is greater than this, okay? Let's see that. Okay, so many different answers, right? So there is exactly one letter between A and T. So again, if we talk about at what places A and T can appear, right? So again, if you think about A and T can appear at what places, so I'll just do one thing. I'll just write the number of scenarios. Can I say if A is at 1, then T can be at 3? It can be 1, 3. A at the first place, T at third place, then second, fourth, then third, fifth, and then what? First, third, second, fourth, third, fifth, and 4, 6, 5, 7th, and 6, 8. Overall, how many scenarios? 6 cases, right? And obviously, it can, guys, if we think about this thing, A and T can appear at what places? I'll do one thing. I'll just remove this particular question, okay? A and T can be either at 1/3, first and third places, second and fourth places, third and fifth places, right? After that, fourth and sixth places, fifth and seventh places, or sixth and eighth places. Total, can I say 6 possibilities? Into 2, because they can interchange their places. It can also appear, it can also happen that A is appearing at third place and T is appearing at first place. Means reverse of these, so into 2. Now how many letters are left here? How many letters are left? We know that overall there are a total of 6 letters left that can be arranged in 6 factorial ways. We do not need to worry about this thing, which letter will be between A and T, right? So A and T can be, basically their places can be in 6 ways and they can interchange their places. That's why 2 into 6 factorial. So ultimately, if we try to write the answer, it is 6 into 2 is 12 and 6 factorial is 720. So ultimately our answer will be guys, this into this, that will be 8640, right? So hopefully you guys got it. Done. Okay, so it is 6 factorial into 12. Okay, let's move forward. Another question here, guys. That is the fifth part, A appears before T. So we need to count the number of words in which A appears before T. Yes, guys, try to solve this one. We don't know how many letters are between A and T, but A appears before T. Okay. So A appears before T. Yes, guys. So nowhere it is written that immediate, right? So there can be no letter between these two. That means A appears immediately before T, or there is one letter between these two, or 2 or 3 or 4 or 5 or 6, right? Can be anything, right? Okay, so Sally is getting 7 into 6 factorial, that is 7 factorial. Ravi 6 factorial, Ayush 7 factorial, right? Aditi 7 factorial, Varsha 7 factorial, Ankur 7 factorial, Ella Varasi got 6 factorial into 2 into 7. Alan Tom Joseph got again. So guys, I've got two correct answer. One was Ella Varsi, the second was Alan, right? You have done it correctly. So basically the thing is, guys, just think it logically. We don't need to make so many cases. First of all, it appears in our mind that maybe we need to make a total of 7 cases. That is, first one, when A and T are together. Second one, when there is exactly one letter between A and T. Third, when there are 2 letters between A and T. Then there are 3 letters between A and T, and so on, up to there are 6 letters between A and T. But we don't need to do that. The simple thing is, can I say in all of these arrangement, either A will appear before T or A will appear after T? Guys, either A will appear before T or A will appear after T. So since we just need to count A appears before T, so our answer will be the total number of cases divided by 2. So our answer is 8 factorial divided by 2, or half of this, that is 20,160. So guys, hopefully you got this. We don't need to think about this much that we should make so many cases. Our answer is as simple as this. That's it, guys. Okay. So this thing is done, right? So our, many of you got 7 factorial or 7 into 6 factorial. That is not the correct answer. The correct answer is this one, right? Okay. So let's do one thing. Now suppose the next part is, I believe that is the 6th one. All the vowels appear together all the vowels appear together. Yes guys, try to solve this one. Okay, Arnav got 5 factorial into 4 factorial. Okay. So basically everybody is getting 5 factorial into 4 factorial. Nishad, you said about the last question, what if there are odd number of cases? There can't be, right? If the number of letters is more than 1, then can I say answer will be any factorial greater than 1 factorial? So it will always contain 2. It will always contain 2. It means it will always be a multiple of 2. Means even if we take, let's say, a 5-letter word, right? So then can I say the answer will be 5 factorial by 2 for the last question, okay? So 120 by 2, it comes out to be 60. Got it? So it won't be odd. Okay, so all the vowels appear together. Again, if you think about this thing, how many vowels are there? 1, 2, 3, 4. So there are 4 vowels, E, A, I and O. Let's bound them together, right? And then the consonants are R, L, T, N. So overall how many letters or how many groups are there? This is one group. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these can be arranged in 5 factorial. Now we can also arrange these 4 vowels in how many ways? 4 factorial ways. So 120 into 24, guys, 120 into 24, we will be getting 2880. So that's our answer, guys. It is 2880. Okay. So, okay, guys. So, I believe we have done enough or sufficient number of arrangement question. Now let's talk a bit about NPR and NCR, and when do we apply NPR and when do we apply NCR, right? So first of all, guys, suppose number of ways of arranging R things. Let's say there are R number of things. Out of n distinct things or n different things. The number of ways of arranging R things out of n different things. Not arranging, I'll start with selecting. The number of ways of selecting R things out of n different things. Let's say there are n different things, or let's say there are 10 different things and you need to select 6 of those, right? Then this can be done in how many ways? We call it NCR, or the combination. How many combinations of R things are possible out of n things, and its value is equal to n factorial divided by R factorial into n minus R factorial. So guys, that's the thing here, n factorial upon R factorial into n minus R factorial, right? So let's say out of 10 things you need to select 4 things, right? So it can be done in 10C4, or value will be 10 factorial divided by 4 factorial into 6 factorial. And if you solve this thing, right, basically here I can write 10 into 9 into 8 into 7 into 6 factorial. Now the 4 factorial is equal to 24 into 6 factorial. This and this cancel. Here divided by 3. Here it is 3. Right. So ultimately we are getting 210. So that's the thing here, guys. Let's say you need to select 4 things. Out of 10 things you apply NCR and our answer is 210. Right. Now this was NCR, and when do we apply NPR? right? That is, instead of selecting, had there been this scenario that arranging, right? So for NCR there is the selecting. I'll do one thing, I'll write it here only. So had there been arranging, and arranging ka matlab, guys, arranging means arranging in a row or the distinct clearly defined places, right? Now this will be what? The number of ways of arranging are things out of n different things. So if you need to arrange certain thing, then can I say basically it will be written as NPR, and it involves two steps. It can be done in two steps, and those two steps are, first of all, out of n things you need to select r things. Out of n things you need to select r thing. So first of all you need to do selection, and after that you need to do arrangement. Then you need to arrange these things. Right. So since the task 1 is selection and task 2 are arrangement, you need to perform both of these tasks. So what we will do? We will multiply, right? So NPR is the number of ways of arranging R things out of n different things. For example, let's say there are 10 things, and out of that you need to arrange 4 things. So first of all you need to select 4 things, and then you need to arrange these 4 things, right? So basically NPR, it can be said as selection, as we already know it is NCR, into arrangement, it is R factorial, right? Now the formula for NCR is n factorial divided by R factorial into n minus R factorial, and the arrangement is R factorial. This and this cancel. We can write here NPR, which is n factorial divided by n minus R factorial, right? Okay. So again, as I was taking this example here, right, hopefully this thing is clear, guys. Okay, how do we get NPR from NCR, right? So I'll do one thing, I'll just give you an example, right? Okay, so guys, let's say there are 10 friends, and then let's say there are these 4 chairs, right, these 4 chairs. So in how many ways any 4 friends can sit on these 4 chairs from these 10 friends? So basically what we need to do, in how many ways 4 friends can sit on these 4 chairs, right, from these 10 friends. So basically what we need to do, can I say out of 10 we need to arrange 4. That can be done in how many ways? 10 P4 ways. Now 10 P4 we already know the value, right? But another way of writing this is, guys, how do we find out the value of 10 P4 in a short manner directly? You just need to write 10 numbers. You just need to write 4 numbers, and we'll start from 10 and we'll just keep decreasing 1. That is, first of all 10 into 9 into 8 into 7. Guys, that's our answer, right? Basically we are starting from 10 and we are decreasing each then number by 1 1 1. Basically we are going reverse, and we will just write 4 numbers. That is 10 into 9 into 8 into 7. Now let's just multiply, right? 7 into 8 is 56, 56 into 9 is 504 into 10. So basically we are getting 5040, right? Hopefully this thing is clear. The difference between NCR and NPR, right? So guys, that's the way that directly we need to find out how we can find out the value of NPR, right? Okay. Now again, acha guys, agar here if you remember, if we need to find out the value of 10 CR, right, had the question been in how many ways can these 10 friends be selected, can I say it will simply be the NPR divided by the number of ways of arrangement, and the number of ways of arrangement is what? It is 4 factorial, isn't it? We can go for reverse, na? Since we know NPR is NCR into R factorial, we can also say NCR is NPR divided by R factorial. So here R is equal to 4. If we had to find out 10C4, then the value will be this, right? Which is, in place of this I can write 24. Now just simply divide, right? this and this cancel, we got here 3 and 3. Ultimately our answer would be 210 that we just found a few minutes ago, right. So guys, I believe our time, we do not have much time here, so we will continue this thing if required, right, in the next session, right. So have a great day guys, bye bye.